This week and also on your test two, I think I didn't indicate where test two will end, but for this week, you're adding and subtracting rational expressions. And so let's look start looking at just this first problem. So number one, we have 6 divided by y to the seventh v squared plus 11 divided by y to the third v to the fifth. Okay, now whenever you are adding and subtracting rational expressions, the denominators must be the same. Notice that these denominators are different. Somehow we have to get these denominators to be the same, and that's where the least common denominator comes into play. So the first thing you got to do is you have to find the least common denominator. That's the first thing you have to do. Now remember, in a previous lesson, the steps to finding the least common denominator of two or more rational expressions. First thing you do is you factor each denominator completely. Not the numerator, just the denominator. Number two, the least common denominator is the product of all the different factors that you see from step one, each raised to a power that's equal to the greatest number of times that the factor appears in any one denominator. So in other words, if we go back to this one, notice that these denominators are monomial factors. So there's nothing else you can do in terms of factoring. So step number one has already been done. Step number two says, all right, if I want to find the least common denominator, I got to take all these different factors that I see. So notice I see a y, see that? And I see a v. Those are the only two different unique factors I see. I see a y and I see a v. But remember, it says this. These factors that you write here, these unique factors, you have to now use the exponent that shows up the greatest number of times. So in other words, if you look at y here, there are 7 factors of y here. There are 3 factors of y in this one. So you can use the largest number. So you can use 7. Then for v, there are 2 factors here. There are 5 factors here. You got to use the largest one. So I got to use 5. So that's your least common denominator. Once you find the least common denominator, the next step, so these are the steps to adding and subtracting now. So we found the least common denominator. The next step is to rewrite each rational expression as an equivalent expression with that denominator, with that least common denominator. So in other words, here's what you're going to write next. So I want to rewrite this fraction, this rational expression, and this rational expression having this denominator. So you're going to go right underneath, leave some space here, you go right underneath, and you're going to write the LCD, y to the 7th, v to the 5th, plus y to the 7th, v to the 5th. So you're going to write equivalent rational expressions with that denominator. All right, now to do this, you're going to ask yourself this. If you look at what you had before with the LCD, what do I need to multiply? So you have to multiply both numerator and denominator by some factor that gives you this. So notice I already have a y to the 7th. I have a v squared here, but I want v to the 5th. So I need 3 more factors of v, right? So 2 plus 3 is 5. So you're going to multiply this rational expression by v cubed. What I do to the denominator, I do to the numerator. So now this rational expression here is equivalent to 6 times v cubed. And then notice y to the 7th, which is this, and v cubed times v squared is v to the 5th. So this rational expression is equivalent to this one. So that's what this says right here. So rewrite each rational expression as an equivalent expression whose denominator is the LCD. So this that I have circled is equivalent to this. All right, so to get this denominator equal to the LCD, you've got to multiply both denominator and numerator because you got to keep it the same by the same factor, but you want to make sure that whatever you multiply it by will give you this denominator. So v cubed times v squared is v to the fifth. So if I multiply the denominator by v cubed, I got to multiply the numerator by v cubed. Now over here, if you notice what I have, so again, you got to do the same thing. You got to do the same thing. You're going to multiply both numerator and denominator by some factor that gives you this denominator. This time, notice I have v to the fifths are the same. So it's the y's that are different. I have 3 here. So if I have 3, I've got to multiply the denominator by y to a power. They'll give me y to the 7th. So 3 plus 4 is 7. So what I do to the denominator, I do to the numerator. And so now this rational expression that I started out with is now equivalent to 11 y to the 4th divided by y to the 7th, v to the 5th, which is my LCD. So that was step 2. Now we're going to do some more, so it'll get a little bit clearer as we go on. But that was step 2. Now once you get the denominators to be the same, then the next step is to write, this is what it says, the next step is to add or subtract the numerators, and then write it with that common denominator. So in other words, you're going to say 6v cubed plus 11y to the 5th, 6v cubed plus 11y to the 5th, divided by that common denominator, which is y to the 7th, v to the 5th. So that was step 3. Step 4, once you get to this rational expression, you got to simplify it if you can. So you got to remember that step 4, you're not done here because you got to do a step 4. So step 4 says simplify or write the rational expression in simplest form by reducing common factors. Well, that's where, if you recall, you have to factor numerator and denominator now. But notice in the numerator, there's nothing to factor. So you're done. This is the answer. You can't do anything else. All right, so that's the answer there. So that's number 1. Let's look at number 2. In number 2, we have 5 divided by x plus 5 minus 2 divided by x minus 5. So if we go through the same process, the first thing we got to do is we have to find the least common denominator. So to find the least common denominator, we have to factor each denominator completely. Well, notice that these two denominators, I cannot do anything further with it. They cannot be factored any further. The GCF in both cases is 1, and there's nothing else you can do. So now to find the least common denominator, remember what it says. The least common denominator is the product, so multiplication, the product of all the different factors that you see. So I want you to see this. I see an x plus 5, so that's got to be in my least common denominator. I see an x minus 5, that has to be in my least common denominator. And then the question is, or the next thing is to think about this, raised to a power that's equal to the greatest number of times that factor appears in any denominator. So all that means is this: x plus 5 occurs once here, it doesn't occur any times here, so I just need 1. X minus 5 occurs once here, it doesn't occur any times here, so I just need 1. So that's your least common denominator. Notice, make sure you put it in parentheses like I have, because it's two binomials multiplied together. So x plus 5 times x minus 5, so that's your least common denominator. Once you find your least common denominator, the next step now is to rewrite those equivalent fractions. So you can go right under this, and notice there are two fractions here. You're going to write under this, leave some space here, and you're going to write this as with the LCD as the denominator now. X plus 5, x minus 5, minus, and then x plus 5, x minus 5. So what you want to do is you want to get, see right now you can't do anything with these fractions because the denominators are different. In order to add or subtract fractions, you have to have the same denominator, so that's where the least common denominator comes into play. And always make sure you're using the least common denominator, not just any common denominator, but the least. See, if you made this up here a 2 and this a 3, that's no longer the least. It's a common, but it's not the least, and it makes things a lot more difficult for you. So that's why you got to use The least. Make sure it's the least that you are using. Okay, so let's go about writing equivalent fractions. So notice I have an x plus 5 here. I want this though. I want to get this denominator. So I have my x plus 5, see right here? So if you need to, you have the x plus 5 covered up. And so what's missing is this. So you don't see an x minus 5 here. So you're going to say times x minus 5 times x minus 5, just like that. So what I do to the denominator, I do to the numerator. And so now what happens is, notice that this rational expression right here is now equivalent to this rational expression with this numerator. But be careful, because this 5 is being multiplied by this binomial. So you got to put it like this. You got to say 5 times x minus 5. That's how it looks. All right, so this times this times this. See, this times this is right here, and then this times this is this. Now, what some students make a mistake is they intuitively want to divide out these x minus 5s. Don't do that, because if you do that, if you divide that out, all you have is this original that you got, and that's not going to help you. You see that? You have 5 divided by x plus 5, which is what I had circled. So you don't want to go backwards. You want to go forwards. All right. So don't make the mistake and reduce now. You're going to reduce at the end if you can. All right. So that's how you find this. Now let's talk about this one. So I have an x minus 5. Okay. So I'm going to cover it up. So I'm missing the x plus 5. So I'm going to say times x plus 5 times x plus 5. All right. Now notice, see, this times this, that's this. And so now this rational expression is equivalent to this times this divided by this times this. All right, so that's your step 2. So step 2 was to write equivalent rational expressions. Now step 3, let's talk about step 3. So step 3 is this now. Step 3 is, now since the denominators are the same, you can now write it as one rational expression with that common denominator, x plus 5, x minus 5. And then all you do now is just subtract. See the subtraction here, so you're going to subtract our numerators. So you're going to say, now you can do a couple things here. You can distribute like I'm doing here. You can say 5x minus 25, and then 2x 2x plus 10. But what I would do is I would do this just to make sure I don't make an error. I'm just going to write what I see. So here's what I see. I see a 5 times x minus 5, subtract, just like this, a 2 times x plus 5. That's the way I would do it. And now what you're going to do is you're going to get rid of the parentheses. Get rid of the parentheses, just like that. So now this becomes, your numerator becomes 5x minus 25. Now be careful, you're distributing a negative 2. So negative 2 times x, and then negative 2 times 5 is a negative 10, divided by that common denominator, x plus 5, x minus 5. And now combining like terms, 5x minus 2x is a 3x, a negative 25 and a negative 10 is a negative 35, divided by x plus 5 times x minus 5. And the next step is this. Simplify the rational expression. So simplify this if you can. So remember, to simplify, make sure you factor numerator in the denominator. Well, the denominator is always going to be factored. Is the numerator, you got to factor now. But notice there's nothing I can do in the numerator. The GCF here is 1. So you're done. That's the answer. That's all you do there. All right. So the more you do, the easier it becomes. All right. So let's look at another one. So this will be number 3. So number 3, we have, let's see. So number 3 is going to be this one. It will be 7 divided by x squared plus 9x plus 20 plus, and then over here we're going to have 4 divided by x squared plus 8x plus 15. All right, so remember, the first thing you have to do is find the least common denominator. So to find the least common denominator, you're going to factor the denominators first. You're going to factor. So when I factor this denominator, I get x plus 5, x plus 4. Over here, this becomes, let's see, that'll be x plus 5, x plus 3. All right, so now your least common denominator, remember, your least common denominator is the product of all the different factors that you see. And then you're going to raise it to the largest power that appears. So I see an x plus 5. See that? So I have to use it. I see an x plus 4. I have to use it. I see an x plus 5. I already have it. See that? So x plus 5 occurs once here, once here. You only use one. If you put a 2, it is no longer the least. It becomes a common denominator, and then it's going to make things so much difficult for you. Things are easier for you if you use the least. So that's why you always ask to add these by finding the least common denominator. Then we have an x plus 3, so I got to use it. So I want you to notice this. The least common denominator for these two rational expressions is those three factors. And leave them in factored form. If you multiply this out, it's not going to help you at all. Leave it in factored form. Leave it like this. All right, now, once you find the least common denominator, that's where you write equivalent fractions. So let's talk about that. Let's write equivalent fractions. So remember that you're gonna underneath here, you're gonna write two fractions with that least common denominator. So you're gonna do this now. You're gonna say, you're gonna write these three factors: x plus 5, x plus 4, x plus 3, plus, same thing here, x plus 5, x plus 4, x plus 3. All right. Now, here's what you gotta ask yourself. This is what I had. This is what I want. So I have the x plus 5 and I have the x plus 4, right? So cover them up. I have the x plus 5, I have the x plus 4, so I'm missing the x plus 3. So I got to multiply this by x plus 3 and the numerator by x plus 3. Okay? So now this rational expression is equivalent to a rational expression where the numerator is 7 times x plus 3. And it's always easy to check yourself, because look, if I reduce the x plus 3's here, which you don't, but if you cover it up, what you have is this right here, what you have circled. Okay? So you know you're doing it correctly if you can kind of cover up what they have in common, and what you see visible is what you started out with. All right. So this is equivalent to this, and notice I have my least common denominator so far. All right, let's do this one. So here I have the x plus 5 and have the x plus 3 covered up. X plus 5, x plus 3. What's missing is the x plus 4. So I got to say times x plus 4. But what I do to the denominator, I do to the numerator, times x plus 4. And so right here, this becomes 4 times x plus 4. And so now I want to show you something. This right here looks just like we did this one. All right, so we're at this step now. Except this is addition, so addition's easy to deal with. So remember the next step we did here, if you recall, was I wrote this as one rational expression. All right, so the next thing you're going to do is you're going to write this as one rational expression with that common denominator. So x plus 5, x plus 4, x plus 3. And now you're going to say this plus this plus this in the numerator. 7 times x plus 3 plus 4 times x plus 4. And now get rid of the parentheses. Distribute now. So I get, in the numerator, I get 7x plus 21. And then over here, distribute the 4, I get 4x plus 16. Divided by the LCD, which is x plus 5, x plus 4, x plus 3. Combining like terms, 7x plus 4x is 11x. 21 plus 16 is 37. divided by your LCD, your common denominator, x plus 5, x plus 4, x plus 3. So once you get, so all of this is step 3. Step 4, remember, is this. Step 4 is where you're going to simplify the rational expression. And remember, to simplify a rational expression, you factor both numerator and denominator. Well, remember, the denominator is always going to be already factored. It's the numerator you're just going to factor. But notice that the numerator, the GCF, is 1, so there's nothing else you can do. So that was number 3. All right, let's go to number 4. So notice it took me, now I wrote kind of big here, but it took me half a page. So I'm gonna have to go to another page. But that's the work you're gonna do. So on the worksheet you turn in, you have to make sure it looks just like this. All right, and see, it's readable. I can read what I'm writing. So make sure when you do this, I'm able to read what you write, and it looks just like this. All right, let's look at number 4. So number 4, we have 3 divided by n squared minus 10n plus 9 minus 4 divided by n squared minus 4n minus 45. So I'm subtracting this time these two rational expressions. The denominators are different, so I've got to find the least common denominator. So to find the least common denominator, remember, you got to factor first. So to factor this is going to be n minus 9, n minus 1, and this will be n minus 9, n plus 5. That's what this one is. And so remember, the least common denominator is going to be the product of all these different factors that you see. So I have an n minus 9, I have to put in my least common denominator. I have an n minus 1, I have to put in my least common denominator. I have an n minus 9, I already have it. Don't include it again. If you put a 2, it's no longer the least, it's a common. And if you're dealing with a common denominator and not the least, you're going to have difficulties going through the process. And then the next factor you see is that n plus 5. So again, this time you have 3 factors again. So that's your least. Now once you find the least, remember the next step is to write equivalent expressions with that least common denominator. So then you're going to go right underneath this, and you're going to write 2 rational expressions with that denominator. So you can say n minus 9, n minus 1, n plus 5, n minus 9, n minus 1, n plus 5. And now, just like we've been talking about, you want to determine what rational expression, this rational expression is equivalent to what rational expression with this denominator. So I have the n minus 9, I have an n minus 1, I am missing the n plus 5. So you're going to say times n plus 5 times n plus 5. So now this rational expression I have circled is now equivalent to a rational expression with this numerator now. 3 times n plus 5. Make sure you put that n plus 5 in parentheses. Now let's do this one now. So I have the n minus 9 and I have the n plus 5. So all I need now is the n minus 1. So I'm going to multiply this by n minus 1. What I do to the denominator, I do to the numerator. So now this rational expression is equivalent to a rational expression having this numerator, 4 times n minus 1. Once you get to that step, then now you have 2 rational expressions with the same denominator. So you're going to write it as 1 now. So you're going to say n minus 9, the denominator, n minus 1, n plus 5. And now the numerator, you're going to say this minus this. So you're going to say 3 n plus 5 minus 4 times n minus 1. And now you're just going to distribute. Get rid of the parentheses. So this becomes, the numerator becomes 3n plus 15. And then a negative 4 times n. And a negative 4 times a negative 1 is a positive 4. Divided by the least common denominator. Don't multiply this out. Leave it in factored form. N minus 9, n minus 1, n plus 5. Now combining like terms, I get 3n minus 4n is a negative n. 15 plus 4 is 19, divided by your least common denominator, n minus 9, n minus 1, n plus 5. And now step 4, once you get to that point, you need to reduce if you can. So remember to reduce, and that was 2 weeks ago or 3 weeks ago that you dealt with this, reducing rational expressions. So that's where you have to factor the numerator and the denominator. The denominator will always be factored because that's how you find your least common denominator. The numerator you got to factor now, but notice the GCF here is 1 or negative 1, so there's nothing else you can do. So there is your answer. So that was number 4. All right, let's look at number 5. All right, in number 5, we have this. We have 4 divided by x squared minus 12x plus 32 plus 6 divided by x squared minus 2x minus 8. So notice that these denominators are different. Before I can add or subtract rational expressions, the denominators have to be the same. So I got to find the least common denominator. Well, to find the least common denominator, I've got to factor these denominators. So this one I can factor as x minus 8, x minus 4. And this one I can factor as x minus 4, x plus 2. And so now your least common denominator will involve every unique factor that you see. I see an x minus 8, I have to use it. I see an x minus 4, I have to use it. I see an x minus 4, I already have it. I see an x plus 2, I have to use it. So your least common denominator is the product of these factors. There's your least common denominator. So now the next step is to do those equivalent expressions now with that least common denominator. So right underneath here, you're going to write two rational expressions with that denominator. So you're going to say just like this, and you're going to put in your denominator the LCD. So x minus 8, x minus 4, x plus 2, x minus 8, x minus 4, x plus 2. All right, and so now you're going to write equivalent fractions. So you want to rewrite this rational expression. You want to write an equivalent rational expression for this that has this denominator though. So you have these two factors. You want these three factors instead. So I have an x minus 4, x minus 8 already. So I'm missing the x plus 2. So you can say times x plus 2 times x plus 2. And so now this rational expression is equivalent to a rational expression with this LCD that has this numerator. And the numerator is 4 times x plus 2. And remember we talked about, so you know you're doing this correctly is if you reduce your common, you're not going to do it, but if you cover it up, what's visible is what's circled. Okay? Now let's do the next one. So here I have an x minus 4, x plus 2. X minus 4, x plus 2, I cover that up, so I'm missing the x minus 8. So I'm going to say times x minus 8, what you do to the denominator, you do to the numerator. So this rational expression is equivalent to a rational expression with this LCD that has this numerator now. 6 times x minus 8. 6 times x minus 8. And again, notice if you see how the x minus 8s here are the same. If you cover it up, what's visible is what's circled. All right, now the denominators are the same. So now you're going to write this as one rational expression with that denominator. X minus 8, x minus 4, x plus 2. And so now the numerator is going to be this plus this. This plus this. So 4 times x plus 2 plus 6 times x minus 8. And the next step is to distribute. So I get, let me go do that underneath here. So I get 4x plus 8. And then if you distribute the 6, you get 6x minus 48. Divided by the LCD, which is x minus 8, x minus 4, x plus 2. Combining like terms, 4x plus 6x is 10x. 8 minus 48 is a negative 40, divided by x minus 8, x minus 4, x plus 2. So now we're at this step now, step 4. So once you get to that point, you got to simplify if you can. In the previous 4 problems, we could not simplify. But here I can, because notice the GCF here is 10. I can factor out a 10. So if I factor out a 10, look what happens. The numerator is 10 times x minus 4. See that? That's this. And then over the LCD, which is x minus 8, x minus 4, x plus 2. And now notice I can reduce the x minus 4's, and so your answer is 10 divided by x minus 8, x plus 2. All right, so once you get to that point, you're not done. You got to factor, you got to reduce if you can. And so you got to remember, you got to factor the numerator. The denominator will always already be factored. And if you can factor and you can reduce, then go ahead and do so. All right, so that's the answer to that one. Let's look at number 6. So in number 6, we have 6 divided by x squared minus 9x plus 18 minus 2 divided by x squared minus 7x plus 12. All right, so again, notice that these two rational expressions that I'm subtracting have different denominators. You must rewrite these to where they have the same denominator. And to get the same denominator, that's your LCD. So you got to factor first. So when I factor this denominator, I get x, let's see, minus 6, x minus 3. Over here, let's see, that's going to be x minus 4, x minus 3. And now your least common denominator is going to involve every unique factor that you see in all of these denominators. I see an x minus 6, I have to use it. Times, I see an x minus 3, I have to use it. I see an x minus 4, I have to use it. I see an x minus 3, I already have it. So your least common denominator is those 3 different factors multiplied together. Once you find your least common denominator, the next step is to write equivalent rational expressions that are equivalent to these. So you're going to say equal, and remember there are 2 of them, and subtraction in the middle. And so your least common denominator is this. You're going to say x minus 6, x minus 3. That's a minus 3. And then x minus 4. X minus 6, x minus 3, x minus 4. All right. Now what you got to do is figure out what the numerator is. And so to figure out the numerator, you got to write equivalent fractions now. So you have the x minus 6, x minus 3. That's this. So you're missing the x minus 4. So you're going to say times x minus 4 times x minus 4, just like that. So now this rational expression is equivalent to a rational expression having this LCD where the numerator is this times this. So this is 6 times x minus 4. And again, always remember, if you were to cover up what they have in common, the x minus 4's, what's visible is what you started out with. All right, now do the next one. Let's see. I have the x minus 3, x minus 4. So that's this right here. So I'm missing the x minus 6. So you got to say times x minus 6 times x minus 6. So this rational expression is equivalent to a rational expression with this LCD and this numerator, 2 times x minus 6. And again, if you cover up what they have in common, the common factor here, what's visible is what you have circled here, the original fraction. Now the denominators are the same. So now you can write this as one fraction with that denominator, x minus 6, x minus 3, x minus 4. And the numerator will be this, subtract this. So you're going to say 6 times x minus 4, subtract 2, times x minus 6. Now the next step is to distribute. All right, don't forget though, you got to rewrite the LCD, the denominator, x minus 6, x minus 3, x minus 4. So this becomes 6x minus 24. Distribute the negative 2. This becomes a negative 2x plus 12. Negative 2 times negative 6 is a positive 12. Combining like terms in the numerator, this becomes 6x minus 2x is 4x. A negative 24 and a positive 12 is a negative 12. Divided by the LCD, the common denominator, which is x minus 6, x minus 3, x minus 4. Now don't stop there. Remember, there is a final step you have to do. You have to simplify in the rational expression. You got to put in lowest terms now. So the denominator will already be factored. As a numerator, you got to try and factor. And I can factor that numerator because the GCF here is 4. I can factor out of 4. So when I factor out of 4, I get 4 times x minus 3 over the denominator, which is x minus 6, x minus 3, x minus 4. And again, you got to cross these out, and you got to put factors of 1s there. And so the answer is going to be 4 divided by x minus 6, x minus 4. And leave it in factored form. Don't multiply it out. If you multiply this out and you have an error, you're going to lose points and you're going to be very upset. So leave it in factored form. All right, so that was number 6. So it's the same process every time. So every problem we've done was the same process. All right, let's look at number 7. All right, number 7. Okay, so in number 7 we have this. We have x plus 2 divided by x squared plus 11x plus 28 plus 10 divided by x squared plus 8x plus 7. All right, and so let's see. Okay, so I'm trying to get the sun out of the way here. All right, so we got to see these two rational expressions have different denominators. So again, in order to add or subtract rational expressions, the denominators have to be the same. So you got to find the least common denominator. All right, so your least common denominator, you got to factor the denominators first. So this right here, I can factor this as x plus 7 times x plus 4. And this one I can factor as x plus 7 times x plus 1. And so the least common denominator is going to involve every unique factor that you see. So I see an x plus 7, I have to use it. I see an x plus 4, I have to use it. I see an x plus 7, I already have it. I see an x plus 1, I have to use it. So your least common denominator has these three factors. And so now we're going to write two rational expressions with that LCD. So x plus 7, x plus 4, x plus 1. X plus 7, x plus 4, x plus 1. Okay? And so now we're going to write equivalent fractions. So this right here, I have to rewrite. See, here's my denominator. It has these two factors, but I want these three. I want that LCD. So I have the x plus 7, x plus 4. I'm missing the x plus 1. So you're going to say times x plus 1 times x plus 1. That's x plus 1 here. So now what I have circled, now you got to be careful with this one. What I have circled is now equivalent to this rational expression with that denominator, where the numerator is this times this. Now remember, when we did the previous one, the numerator was a monomial. It was just a number. So we just said 6 times x minus 4. See right here? Now we got to be careful though, because that's a binomial. A binomial times a binomial. So the way you're going to do this is you're going to say x plus 2 times x plus 1, just like I'm writing. Okay, a binomial times a binomial. A binomial times a binomial, just like that. Now that's just a number, so that one's going to be a little bit easier. So x plus 7, x plus 1, that's this one. So I'm covering them up, so I'm missing the x plus 4. So you're going to say times x plus 4 times x plus 4. So now this rational expression is equivalent to a rational expression with this denominator having this numerator, 10 times x plus 4. All right, so notice this right here is different than what this looks. All right, so now I have two rational expressions with the same denominator. So I'm going to write it as one denominator now. So you're going to say x plus 7, x plus 4, x plus 1. And then you're going to say this plus this numerator plus this numerator. So you're going to say x plus 2, x plus 1, plus 10 times x plus 4. Now before we go on, let's go back to the previous one. So notice that in these two numerators, they had the same form, a number times a binomial, a number times a binomial. So we use the distributive property at this point. Okay, here I have two binomials being multiplied together, and then I have a binomial times a monomial. So for this one, I'm going to distribute. Over here, I'm going to FOIL. So let's do the FOIL here. So now this becomes, now I'm going to rewrite the denominator, x plus 7, x plus 4, x plus 1. So if I FOIL this, x times x is x squared. The outer x times 1 is 1x. The inner 2 times x is 2x. And the last 2 times 1 is 2. Okay, so that is this. Then I'm going to distribute this. 10 times x is 10x, so plus 10x. And then 10 times 4 is 40, so plus 40. All right, so all these terms is this numerator. Combining like terms, I get this now. I get x squared. X plus 2x is 3x. 3x plus 10x is 13x. 2 plus 40 is 42. Okay, now divided by the LCD, which is x plus 7 times x plus 4 times x plus 1. All right, now that's where I'm at. So now remember, once you get to this point right here, right here, you got to factor the numerator and see if you can reduce. Notice in this problem, the numerator was a linear factor. Here, the numerator is quadratic. So you got to factor this quadratic numerator here. And so to factor that, let's see, I'm going to go ahead and rewrite the denominator, x plus 7, x plus 4, x plus 1. So here, let's see, for this numerator, you can factor this as x plus 7 times x plus 6. Because x times x is x squared, 42. 7 times 6 is 42. 6x and 7x is 13x. And now you reduce. And you got to show the reducing. And so the answer is x plus 6 divided by this product. So you get x plus 6 divided by x plus 4 times x plus 1. All right, so that's the answer there. All right, so that was number 7. So there are going to be some situations where you're going to end up with a quadratic, and you got to remember to factor that. All right, so that was number 7. Let's look at number 8. All right, number 8. Now let me do this. We're already at 43 minutes on this video, so let me turn this video off and start a new one. So let me go ahead and do that. So I'm going to turn this one off.